आज के इस वीडियो में हम देखेंगे चैप्टर एलिमेंट्स ऑफ ग्रुप 16, 17, 18 का पॉइंट एटॉमिक एंड फिजिकल प्रॉपर्टीज ऑफ ग्रुप 16, 17 एंड 18। उसमें पढ़ेंगे एटॉमिक एंड आयोनिक रेडिया क्या होता है। इट इज नथिंग बट द डिस्टेंस ऑफ आउटरमोस्ट इलेक्ट्रॉन फ्रॉम द न्यूक्लियस। न्यूक्लियस से आउटरमोस्ट इलेक्ट्रॉन का जो भी डिस्टेंस होता है उसको हम बोलते हैं एटॉमिक रेडिया, और ये प्रोपोर्शनल रहता है नंबर ऑफ शेल से। जैसे कि कोई भी एटम में नंबर ऑफ शेल्स इंक्रीज हो जाएंगे, एटॉमिक रेडिया इंक्रीज हो जाएगा। ये रहता है एटॉमिक रेडियस। हम पढ़ रहे हैं एटॉमिक रेडियस के बारे में। ये अलोंग द ग्रुप एंड डाउन द ग्रुप एंड अक्रॉस द पीरियड डिक्रीज और इंक्रीज कैसे होता है उसका ट्रेंड देखेंगे। अगर हम बात करेंगे अक्रॉस द पीरियड की, अक्रॉस द पीरियड मतलब हम ऑक्सीजन, फ्लोरीन, नियॉन ऐसा ट्रेंड देखेंगे अक्रॉस द पीरियड का, तो एटॉमिक रेडियस वो डिक्रीज हो जाता है। ऐसा क्यों होता है? अगर हम देखेंगे एटॉमिक नंबर ऑफ ऑक्सीजन, फ्लोरीन, नियॉन दैट इज 8, 9, 10। अगर हम इनका इलेक्ट्रॉनिक कॉन्फ़िगरेशन देखेंगे इन द ऑर्बिट, हाउ इट विल occurs, 2 electrons will goes in the first orbit, and then for the oxygen how many electrons will goes in the second orbit? 6 electrons, 4, 5, 6 electrons. If we talk about the fluorine, then in this case its atomic number is 9. Then how many electrons will goes in the second orbit? 2 will go in first orbit. 7th electron of fluorine, it enters in the second orbit only. For that electron we are not forming any another orbit, only the second orbit electrons goes on filling. For the neon atomic number 10, then again how many electrons will go in the second orbit? 2 electrons. That is 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons will fill in the outermost orbit. Okay. Then its octet get completed. But what we saw here, no new orbit get formed for the electronic configuration of this oxygen, fluorine and neon. That's why whatever the electrons in the outermost orbit, they get attracted by the same nucleus, and that whatever the Z effect of the nucleus, it occurs more on that outermost orbit, outermost electrons. That's why it's whatever the atomic radius, it is goes on decreasing. जो भी न्यूक्लियस का जेड इफेक्ट रहता है, जेड इफेक्ट के बारे में हम लोग नेक्स्ट स्लाइड में बात करेंगे। अभी के लिए आप इतना याद रखो, जेड इफेक्ट क्या रहता है? जो भी न्यूक्लियस का पॉजिटिव चार्ज रहता है वो उसका इफेक्ट आउटर मोस्ट इलेक्ट्रॉन में जो अकर होता है उसको बोलते हैं जेड इफेक्ट। तो हमने देखा यहाँ पे कि आउटर मोस्ट ऑर्बिट इंक्रीज नहीं हो रहा, सेम ऑर्बिट में इलेक्ट्रॉन्स फील होते जा रहे हैं, तो उनको अट्रैक्ट करने का न्यूक्लियस का जो भी पावर है वो ज़्यादा हो जाएगा और वो मोर इफिशिएंटली अट्रैक्ट करेगा न्यूक्लियस के पास आउटर मोस्ट इलेक्ट्रॉन को, इसीलिए एटॉमिक रेडियस डिक्रीज हो जाएगा। अगर हम बात करेंगे अक्रॉस द ग्रुप की, डाउन द ग्रुप की, तो अजय यहाँ पे ऑक्सीजन का एटॉमिक नंबर रहता है 8, सल्फर का रहता है 16, सेलियम 34, टेलोरियम 52, पोलोनियम 84। तो हम जब इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन देखेंगे तो ऑक्सीजन का आ जाएगा 2, 8, सल्फर का देखेंगे तो 2, 8, 6, आउटरमोस्ट ऑर्बिट में 6 इलेक्ट्रॉन्स आ जाएंगे। बट यहाँ पे डिफरेंस क्या दिखाई दे रहा है हमें कि थर्ड ऑर्बिट गेट एंटर्ड इन द सल्फर एटम। अगर हमें सेलोनियम का, टेलोरियम का, पोलोनियम का इलेक्ट्रॉनिक कॉन्फ़िगरेशन लिखना है तो सेम ऑर्बिट में हमें इलेक्ट्रॉन फिल नहीं करने पड़ेंगे, क्योंकि हमें उसके लिए न्यू ऑर्बिट चाहिए। तो जो भी नंबर ऑफ ऑर्बिट्स है यहाँ पे डाउन द ग्रुप वो इंक्रीज हो जाएंगे, तो इसके लिए एटॉमिक रेडियस जो है वो इंक्रीज हो जाएगा व्हेन वी गो डाउन द ग्रुप। तो इसीलिए इसका ट्रेंड है एटॉमिक रेडियस का, व्हेन वी गो डाउन द ग्रुप it goes on increases, and when we go across the period then it goes on decreases. This is all about the atomic radius and ionic radius. आइए समझते हैं इफेक्टिव न्यूक्लियर चार्ज क्या होता है। द नेट पॉजिटिव फोर्स experienced by an electron inside an atom, that is the effective nuclear charge. That is whatever the force applied on the outermost electrons by the nucleus, that is effective nuclear charge. इसके लिए हम एक एग्जाम्पल लेते हैं सोडियम का। As we know, the electronic configuration of sodium is 2 and 8. Now here how many orbits are present here? 3 orbits. In the first orbit 2 electrons will get filled. In the second orbit 8 electrons get filled, and in the outermost orbit 1 electron present. Here we have to calculate effective nuclear charge on the third orbit electron, whatever that 1 electron present in the outermost orbit. Then for calculating that we have the formula Z effect. That effective nuclear charge we are denoting it with the Z effect. It is equal to Z minus S. Z means number of protons, that is atomic number we are showing by the Z. That we will calculate. Z is protons, total protons present in the atom, and S is nothing but the inner electron. Now which are the inner electrons in this case? In the case of sodium, how many orbits are present? Whatever that fulfilled, it is the first and second orbit. Then in that 2 orbits are inner, whatever the orbits present near the nucleus, that we will call the inner orbits. In the inner orbits how many electrons are there? 10 electrons are there. Then here if we calculate that, Z effect is equal to 11 minus 10. It is equal to 1. That is the effective nuclear charge on the electron which is present in the third orbit of the sodium is the 1. Let us take another example for this. Now here in this case we took the chlorine atom and we are going to calculate the effective nuclear charge of the electrons present in the n is equal to second orbit, in the whatever the electrons present in the second orbit of the chlorine, that we will calculate the effective nuclear charge. Now what's the formula? E effect is equal to Z minus whatever the electrons present in the inner orbit. Okay, then we have to calculate the n is equal to 2. सेकेंड ऑर्बिट में कितने इलेक्ट्रॉन्स है? 8 इलेक्ट्रॉन्स है. उस पे इफेक्टिव न्यूक्लियर चार्ज कितना है हमें कैलकुलेट करना है. सेकेंड ऑर्बिट के लिए इनर ऑर्बिट कौन सा रहेगा? n इज इक्वल टू 1 वाला, मतलब फर्स्ट ऑर्बिट रहेगा इनर ऑर्बिट. तो इनर ऑर्बिट में कितने इलेक्ट्रॉन्स है? 2. तो Z इफेक्ट कैलकुलेट करने के लिए हमें प्रोटॉन कितने मिलेंगे? व्हाटएवर द एटॉमिक नंबर Z माइनस 2. Z मतलब इसका एटॉमिक नंबर कितना है क्लोरीन का? 17 माइनस व्हाटएवर द inner electrons present in the first orbit, that is 2. Then we get 15 as the effective nuclear charge for n is equal to 2. It means whatever the electrons present in the second orbit, they feel the effective nuclear charge, that is 15. अगर हम बात करें पीरियोडिक ट्रेंड की along the period and through the group, along the group, then why effective nuclear charge increases across the period? उसका क्या रीजन है? That is number of shells remain constant, means जो भी इलेक्ट्रॉन फील हो रहे हैं वो सेम ऑर्बिट में हो रहे हैं. There is no increase in number of orbits or number of shells when we are going from across the period, from left to right, and atomic number is goes on increasing, but electrons are going in the same orbit. But in the case of group, if we go down in the group, what we see? Number of orbits, number of shells goes on increasing. That's why whatever the effective nuclear charge filled by the outermost electron, it is goes on decreasing. उसका जो भी अट्रैक्शन फोर्स रहेगा, जो भी बाइंडिंग रहेगा न्यूक्लियस के साथ, अगर उसके ऑर्बिट्स, नंबर ऑफ ऑर्बिट्स बढ़ रहे हैं और एक लास्ट के ऑर्बिट में जो भी इलेक्ट्रॉन फील होगा उसका अट्रैक्शन कम होता जाएगा. इसीलिए इफेक्टिव न्यूक्लियर चार्ज also goes on decreasing down the group, and if we see it across the period, it is goes on increasing. This is the periodic trend. शील्डिंग इफेक्ट क्या होता है देखते हैं. ड्यू टू द पॉजिटिव प्रोटॉन, न्यूक्लियस exerts the inward force on the electrons called the nuclear attraction. न्यूक्लियर एट्रैक्शन क्या होता है? न्यूक्लियस में पॉजिटिव चार्ज होता है और इलेक्ट्रॉन्स निगेटिवली चार्ज होते हैं, तो इनमें ऑब्वियसली अट्रैक्शन होता है. पॉजिटिव एंड निगेटिव ऑपोजिट पोल्स अट्रैक्ट ईच अदर. That's why nucleus exerts the nuclear attraction force on the electrons, whatever present in the first, second or third orbit. Whatever the electrons present in the atom, on that all electrons nucleus exerts the positive attraction force. अब अगर समझते हैं यहाँ पे हम शील्डिंग इफेक्ट क्या होता है, तो वो होता है कि जो भी इनर इलेक्ट्रॉन्स है ऑर्बिट में वो आउटर मोस्ट इलेक्ट्रॉन को प्रोटेक्ट करते हैं बाय गेटिंग अट्रैक्टेड टूवर्ड्स द न्यूक्लियस. बस यही होता है शील्डिंग इफेक्ट की, उसका अट्रैक्शन फोर्स ऑफ द न्यूक्लियस एंड आउटर मोस्ट इलेक्ट्रॉन इट गेट रिड्यूसेस बिकॉज ऑफ द whatever electrons present in the inner orbits. That is the shielding effect. ट्रेंड ऑफ शील्डिंग इफेक्ट अक्रॉस द पीरियड अगर देखेंगे तो हमें पता है कि if we go across the period there is no increasing number of orbits as its atomic number goes on increasing across the period, but orbits are not goes on increasing in the same orbits. Electrons are going on filling on the same orbit as we go across the period. That's why no orbit increases. It means no shielding effect increases or decreases across the period. When we are going from left to right in the period, we get that shielding effect remains constant from left to right. What is the reason behind this? Because there is no increase in number of orbits. That's why this shielding effect across the period remains the constant. Question can be asked on this. That is why the shielding effect across the period remains constant. Then this is the reason. If we see this shielding effect down the group, we get that it is goes on increasing, because as the number of orbits goes on increasing down the group, as its atomic number goes on increasing, और number of orbits also goes on increasing. अगर जितने ज़्यादा ऑर्बिट रहेंगे न्यूक्लियस एंड आउटर मोस्ट इलेक्ट्रॉन के बीच में उतना ज़्यादा शील्डिंग इफेक्ट रहेगा. हमें पता है व्हाट इज द ट्रेंड ऑफ atomic number atomic radius goes on increasing down the group. Like that only shielding effect also goes on increasing down the group. Now what is the ionization enthalpy? Minimum amount of energy required to remove outermost electron of an isolated gaseous atom to form a cation. That is nothing but the ionization enthalpy. जो भी अमाउंट ऑफ एनर्जी रिक्वायर्ड है आउटरमोस्ट इलेक्ट्रॉन, जो भी वैलेंस इलेक्ट्रॉन है उसको रिमूव करने के लिए, बट कौन से एलिमेंट्स में, कौन से एटम में? आइसोलेटेड गैसियस एटम. आइसोलेटेड मतलब क्या होता है? अलोन, एक ही एटम के बारे में हम यहाँ डिस्कस करेंगे, नॉट बल्कि मॉलिक्यूल के फॉर्म में, सिंगल एटम्स के बारे में ही आयोनाइजेशन एंथैल्पी कैलकुलेट कर सकते हैं. टू फॉर्म द cation. To form a cation, why? Because after removing outermost electron, that atom gets the positive charge. That's why here written atom forms a cation. हमने previous slide में discuss किया nuclear charge and shielding effect के बारे में, because we have to learn here what are the factors affecting the ionization enthalpy. Ionization enthalpy के लिए कौन से factors अफेक्ट करते हैं, इसीलिए हमने पढ़ा न्यूक्लियर चार्ज एंड शील्डिंग इफेक्ट के बारे में. तो कौन से फैक्टर्स है? साइज ऑफ एन एटम. अगर एटम का साइज गोज ऑन इंक्रीजिंग हो रहा है तो आयोनाइजेशन एंथैल्पी ऑब्वियसली डिक्रीज हो रहा है, मीन्स इट इज इनवर्सली प्रोपोर्शनल. एटॉमिक साइज एंड आयोनाइजेशन एंथैल्पी दे आर इनवर्सली प्रोपोर्शनल टू ईच अदर. अगर न्यूक्लियर चार्ज के बारे में बात करें तो आयोनाइजेशन एंथैल्पी is directly proportional with the nuclear charge. And shielding effect, this is also inversely proportional like the atomic size. If the shielding effect is less, then ionization enthalpy is more, and shielding effect is more, then ionization enthalpy is less. This is inversely proportional relation. These are the factors affecting on the ionization enthalpy. What is the electronegativity? The ability of an atom to attract shared pair of electron pair towards itself in a covalent bond. हमने आयोनाइजेशन एंथैल्पी पढ़ी जो कि आइसोलेटेड एटम के बारे में था, बट अगर हमें इलेक्ट्रोनेगेटिविटी पढ़ना है तो हमें कोवैलेंट बॉन्ड एंड शेयर्ड पेयर्ड इलेक्ट्रॉन्स के बारे में बात करनी है। तो कौन कौन से फैक्टर्स अफेक्ट करेंगे इलेक्ट्रोनेगेटिविटी के लिए, आइए देखते हैं। फैक्टर्स अफेक्टिंग ऑन द इलेक्ट्रोनेगेटिविटी, दैट इज द न्यूक्लियर चार्ज। दिस इलेक्ट्रोनेगेटिविटी इज डायरेक्टली प्रोपोर्शनल विद द न्यूक्लियर चार्ज। एक एग्जाम्पल के द्वारा देखेंगे इसको। अगर हम कोई भी दो एटम्स लेंगे P and Q, दे आर मेकिंग द कोवैलेंट बॉन्ड बाय शेयरिंग द 2 इलेक्ट्रॉन्स। अगर इलेक्ट्रोनेगेटिविटी क्या होता है, जब दैट इज द पावर, दैट इज द फोर्स हैव द एटम विच अट्रैक्ट बोथ द इलेक्ट्रॉन्स, दोनों भी इलेक्ट्रॉन्स को अट्रैक्ट करने की पावर होती है इलेक्ट्रोनेगेटिविटी। अगर हम इस केस में देखेंगे P and Q forming the covalent bond by sharing the electrons, then as we see Q have the electronegativity more and P have the less electronegativity. That's why Q will attract both the electron pairs towards its. That's why it has the more electronegativity. Electronegativity means that shared paired electrons, both electrons will get attracted towards the one atom. That electronegativity is directly proportional to the nuclear charge. उसका जो भी इलेक्ट्रॉन अट्रैक्ट करने की पावर है वो भी न्यूक्लियस में रहेगी। अगर उसका एटॉमिक नंबर ज्यादा रहेगा तो ऑब्वियसली इलेक्ट्रॉन्स को जल्दी अट्रैक्ट करेगा, इसीलिए इलेक्ट्रोनेगेटिविटी डायरेक्टली प्रोपोर्शनल होती है न्यूक्लियर चार्ज से। अगर हम बात करें एटॉमिक रेडियस के बारे में, इलेक्ट्रोनेगेटिविटी इज इनवर्सली प्रोपोर्शनल विद द एटॉमिक रेडियस। अगर एटॉमिक रेडियस ज्यादा है तो इलेक्ट्रोनेगेटिविटी कम है। इट इज इनवर्सली प्रोपोर्शनल विद द एटॉमिक रेडियस। इलेक्ट्रोनेगेटिविटी इज इनवर्सली प्रोपोर्शनल विद द एटॉमिक रेडियस। आइए पढ़ते हैं अभी फैक्टर्स अफेक्टिंग इलेक्ट्रोनेगेटिविटी। कौन से फैक्टर्स है? एटॉमिक साइज, न्यूक्लियर चार्ज एंड शील्डिंग इफेक्ट और द स्क्रीनिंग इफेक्ट। शील्डिंग इफेक्ट को ही हम स्क्रीनिंग इफेक्ट भी कहते हैं। जैसे आयोनाइजेशन एंथैल्पी देखा था वही सेम ट्रेंड फॉलो करता है इलेक्ट्रोनेगेटिविटी। इलेक्ट्रोनेगेटिविटी ऑल्सो इनवर्सली प्रोपोर्शनल विद द एटॉमिक रेडियस एंड इनवर्सली प्रोपोर्शनल विद द shielding effect, like the ionization enthalpy also inversely proportional with the atomic radius and shielding effect. Then electronegativity is directly proportional with the nuclear charge. आपको दोनों randomly याद रखना है। ionization enthalpy and electronegativity both have the same factors affecting on that, that is atomic size and shielding effect inversely proportional and electronegativity is directly proportional with both ionization enthalpy and electronegativity. अगर हम इलेक्ट्रोनेगेटिविटी का ट्रेंड देखेंगे डाउन द ग्रुप एंड अक्रॉस द पीरियड, व्हाट विल बी द ट्रेंड? एटॉमिक रेडियस, as the atomic radius increases electronegativity goes on decreasing. That's why when we go down in the group electronegativity goes on decreasing. If we go across the period, then whatever the nuclear charge it is goes on increasing. That's why electronegativity goes on increasing across the period. You just remember electronegativity increases across the period because nuclear charge, whatever it is, directly proportional with the nuclear charge. Various factors are affecting on the electronegativity that we have learned in the previous slide. That's why here we take 2 points for the taking consideration the trend of electronegativity down the group and across the period. अगर हम डाउन द ग्रुप बात कर रहे हैं तो हमें इसमें रेडियस का पॉइंट कंसिडर करना है। अगर अक्रॉस द पीरियड जा रहे हैं तो न्यूक्लियर चार्ज का पॉइंट कंसिडर करना है। दैट इज डाउन द ग्रुप इलेक्ट्रोनेगेटिविटी गोज ऑन डिक्रीजिंग एंड इफ वी गो across the period electronegativity goes on increasing. इलेक्ट्रॉन गेन एंथैल्पी और इलेक्ट्रॉन एफिनिटी क्या होती है देखते हैं। इलेक्ट्रॉन गेन एंथैल्पी इट इज नथिंग बट द taking electron, feeling electron in the outermost orbit. The enthalpy change that takes place when an electron is added to an isolated gaseous atom. Whatever the energy of that atom will go on changing when any electron enters in that. That is the electron gain enthalpy. कोई भी इलेक्ट्रॉन किसी एटम में हम फील कर रहे हैं तो उसकी एनर्जी चेंज होती है, उसको बोलते हैं इलेक्ट्रॉन गेन एंथैल्पी। अगर इस इलेक्ट्रॉन गेन एंथैल्पी का ट्रेंड हम देखें अक्रॉस द पीरियड एंड डाउन द ग्रुप, then whenever we are going in the periods across the periods, that electron gain enthalpy is more negative, and down the group if we are going in any group from 16 17 and 18, then whatever the electron gain enthalpy it becomes less down the group and it becomes more negative, that atoms are becoming more negative, its electron gain enthalpy becoming more negative if we go across the period, and if we go down the group electron gain enthalpy it is goes on decreasing, it becomes less electron gain enthalpy. Now we are learning about the physical properties of group 16. 16 ग्रुप में जो भी एलिमेंट्स हैं उनके फिजिकल प्रॉपर्टीज के बारे में बात करेंगे। यहाँ पे एलिमेंट्स कौन कौन से हैं 16 ग्रुप में? ऑक्सीजन, सल्फर, सेलेनियम, टेलुनियम एंड पोलोनियम, दीज आर द एलिमेंट्स ऑफ ग्रुप 16। अगर हम स्टेट्स ऑफ एलिमेंट्स देखें कौन से स्टेट में प्रेजेंट रहते, स्टेट मतलब वो कौन से फॉर्म में प्रेजेंट है, सॉलिड, लिक्विड और गैसियस, कौन सा स्टेट है उनका। तो ऑक्सीजन रहता है दैट वी नो ऑलवेज इट इज इन द गैसियस स्टेट। इफ वी talk about the sulfur, selenium, tellurium and polonium, these all elements are in the solid form, in the solid state at the room temperature. If we talk about these are metals, non-metals or metallites, then from that all elements of the group 16, oxygen and sulfur are the non-metals, as all are gaseous state, they are non-metals. Then selenium and tellurium, these are the metallites, and polonium is only one, that is the metal in the group 16. If we talk about the melting and boiling point, it goes on increasing with the increase in the atomic number. It means if we go down the group, then its boiling point and melting point goes on increasing. Then all the elements exhibits the allotropes. These all elements, oxygen, sulfur, selenium, tellurium and polonium, these all have the allotropes. They forms the allotropes. These are the properties, these are the physical properties of group 16 elements. Properties of group 17 elements. Which are the elements present in 17 group? That is fluorine, chlorine, bromine and iodine. अगर उनके states के बारे में बात करें कौन से form में present होता है, तो fluorine and chlorine are present in the gaseous state. Then bromine it present in the liquid form and iodine is present in solid form at room temperature. रूम टेम्परेचर पे फ्लोरीन एंड क्लोरीन गैसियस स्टेट में रहते हैं, ब्रोमीन लिक्विड स्टेट में एंड आयोडीन सॉलिड स्टेट में। अगर इनके कलर के बारे में बात करें तो फ्लोरीन रहता है येलो कलर का, क्लोरीन रहता है ग्रीनिश येलो कलर, ब्रोमीन रेड कलर एंड आयोडीन वॉयलेट कलर। फ्लोरीन रहता है येलो, क्लोरीन ग्रीनिश येलो, ब्रोमीन रेड एंड आयोडीन रहता है वॉयलेट कलर। These are about the colors of these elements. अगर हम इसके बारे में बात करें soluble, so these elements are soluble in water or they are reacting with the water, तो फ्लोरीन एंड क्लोरीन है जो रिएक्ट करते हैं वाटर के साथ, एंड ब्रोमीन एंड आयोडीन आर sparingly soluble in the water, they get dissolved in the water, they are sparingly soluble in the water. Bromine and iodine, fluorine and chlorine, they react with the water. अगर बॉन्ड डिसोसिएशन एंथैल्पी के बारे में बात करेंगे, व्हाट इज द बॉन्ड डिसोसिएशन एंथैल्पी? बॉन्ड ब्रेक करने के लिए जो भी एनर्जी लगती है उसको हम बोलते हैं बॉन्ड डिसोसिएशन एंथैल्पी। तो इसका जो भी फॉर्म है वो क्लोरीन के लिए ज़्यादा एनर्जी लगती है, बॉन्ड डिसोसिएशन एनर्जी क्लोरीन के लिए सबसे ज़्यादा होती है, फिर होती है ब्रोमीन, फ्लोरीन एंड आयोडीन के लिए। इट इज गोज ऑन डिक्रीजिंग as we go from the chlorine, bromine, fluorine and iodine। आपको ये जो भी फॉर्मेट है वो याद रखना है बॉन्ड डिसोसिएशन एंथैल्पी का, एंड जो भी इसके प्रॉपर्टीज है ग्रुप 17 एलिमेंट के, ये बहुत इंपॉर्टेंट है। PYQs में बहुत सारे क्वेश्चंस पूछे गए हैं, वो हम फर्दर डिस्कस करेंगे इसी स्लाइड में। जस्ट टू रिमेंबर दिस पॉइंट्स ऑल। प्रॉपर्टीज ऑफ ग्रुप 18 एलिमेंट्स। 18 ग्रुप में कौन से एलिमेंट्स प्रेजेंट होते हैं? ऑल नोबल गैसेस आर प्रेजेंट इन द 18 group elements। noble gases are monoatomic। what are their properties? they are monoatomic, then they are sparingly soluble in the water, then helium has the lowest boiling point of any known substance। just you remember this point, it is very important। helium has the lowest boiling point, it is 4.2 Kelvin of any other substance। whatever the other substances are that than other elements, this helium has the lowest boiling point। these are the properties of group 18 elements। anomalous behavior of the oxygen। oxygen कैसे differently behave करता है other than the elements present in the 16 group, that we will discuss in this। which are the points we have to discuss here? atomicity, magnetic behavior, then oxidation state, hydrides and covalency। here atomicity अगर बात करें atomicity के बारे में, oxygen present in always diatomic form and other elements are present in the polyatomic forms। magnetic behavior, oxygen behaves as the paramagnetic and other elements are behaving as the diamagnetic। oxidation state, oxygen की हमेशा -2 रहती है because it not have the d orbital, that's why oxygen shows only -2 oxidation state, but other elements which oxidation state they can show -2, +2, +4 and +6। these all oxidation states can be shown by the other elements, but oxygen only showing -2। if we see about the hydrides, hydrides मतलब ऑक्सीजन की एंड अदर एलिमेंट्स की हाइड्रोजन के साथ जो भी रिएक्शन होती है एंड आफ्टर दैट दे आर फॉर्मिंग द हाइड्राइड्स। इफ हम उन रिएक्शंस के बारे में फर्दर वी विल डिस्कस, बट हियर यू जस्ट रिमेंबर अगर ऑक्सीजन हाइड्रोजन के साथ रिएक्ट कर रहा है तो हमें पता है वो वाटर बनाता है एंड विच इज इन द लिक्विड फॉर्म। बट अदर एलिमेंट्स जो भी ग्रुप 16 में है वो अगर हाइड्रोजन के साथ रिएक्ट कर रहे हैं एंड हाइड्राइड्स फॉर्म कर रहे हैं, दैट ऑल आर प्रेजेंट इन द गैसियस स्टेट, ओनली ऑक्सीजन प्रेजेंट इन द liquid form, liquid state, that's why it's anomalous behavior oxygen showing। then next one is the covalency। oxygen shows the covalency 2 and in the rare cases it shows the 4, but other elements what are present in this group they can exceeds the covalency 4। this is the anomalous behavior of the oxygen। anomalous behavior of the fluorine। इसमें हम डिस्कस करेंगे फ्लोरीन कैसे डिफरेंटली बिहेव करता है, व्हाट आर द एलिमेंट्स अदर एलिमेंट्स प्रेजेंट इन द ग्रुप 17। आयोनाइजेशन एंथैल्पी, इलेक्ट्रोनेगेटिविटी, इलेक्ट्रोड पोटेंशियल all are the high in the fluorine atom other than the other elements present in the group 17। then ionic radii, covalent radii and negative electron gain enthalpy are the quite lower in the fluorine। most of the reactions of fluorine are exothermic। it forms only the one oxyacid, that is HOF, while other halogens can form the number of oxyacids। hydrogen fluoride is a liquid. It hydrogen fluoride, it present in the liquid form, while other halides are in the gaseous state. Like the oxygen only, oxygen also forms the hydride in the liquid form, and other are forming the gaseous. Like that only hydrogen fluoride, it is in the form of liquid, and other halogens form whatever the halides with that, they are in gaseous state. Then fluorine exhibits oxidation state -1 only, and other halogens can show +1, +3, +5 and +7 oxidation state. This is the anomalous behavior of the fluorine. अब हमने जो भी एटॉमिक एंड फिजिकल प्रॉपर्टीज ऑफ द एलिमेंट्स ऑफ ग्रुप 16, 17, 18 ये पॉइंट पढ़ा, उसके ऊपर हम लोग कुछ PYQ सॉल्व करेंगे. उसमें क्वेश्चन नंबर 1 है, विच ऑफ द फॉलोइंग हैज द हाईएस्ट इलेक्ट्रोनेगेटिविटी वैल्यू. ऑप्शंस आर फ्लोरीन, क्लोरीन, ब्रोमीन एंड आयोडीन. As we know that fluorine shows the anomalous behavior from its group, then as we go down the group, electronegativity goes on decreasing. That's why here option number B is the correct answer for this question. Chlorine shows the highest electronegativity. Question number 2. Identify a metalloid from the following list of elements. Options are carbon, neon, sodium and tellurium. As we know that carbon is the non-metal, neon is gaseous state, sodium present in it is the metal, and tellurium only the metalloid. That's why for this question D is the correct answer, that is tellurium. Question number 3. Which halogen has the highest value of negative electron gain enthalpy? Here, we have learned about the electron gain enthalpy. In that we have seen as we go down the group, electron gain enthalpy goes on decreasing. That's why if we check options fluorine, chlorine, bromine and iodine, from that option number B is the correct answer, because fluorine shows the anomalous behavior. Then we are not considering that, then chlorine has the highest value of negative electron gain enthalpy. Question number 4. Which element among the following does not form diatomic molecule? Options are argon, oxygen, nitrogen, bromine. From that, option A is the correct answer. Argon not form the diatomic molecule. Question number 5. The correct decreasing order of energy released when an electron is added to neutral gaseous halogens is. Now यहाँ पे आपको पूछा है कि इलेक्ट्रॉन गेन एंथैल्पी की एनर्जी थ्रू आउट द हैलोजन एटम्स क्या होती है. तो उसके लिए ट्रेंड रहेगा like the chlorine, fluorine, bromine and iodine. Electron gain enthalpy of the chlorine is more than fluorine, bromine and iodine. Then option number D will be the correct answer. Question number 6. Which among the following is pale yellow gas? Fluorine, bromine, chlorine or iodine? From that option number A is correct. Fluorine is a pale yellow gas. Question number 7. Which from the following elements of halogen family is in liquid state at room temperature? Options are iodine, astatine, fluorine, bromine. From that option number D is the correct answer. It is only in liquid state at room temperature. Question number 8. Which element from following is most electronegative? Chlorine, astatine, bromine or oxygen? From that option number D is the correct answer, oxygen. Question number 9. Which element from the following has the smallest atomic size? Options are bromine, tellurium, iodine and polonium. Here we have to consider the atomic size along the group and across the periods also. As we know that atomic size increases down the group and it decreases across the periods. That's why whenever we are checking and arranging this atomic size of all the elements in the options, then it will become first polonium will come, then tellurium, then iodine and bromine. Then if we check which element has the smallest atomic size, that is the bromine. Then option number B is correct answer for this. Question number 10. Identify the elements having smallest atomic radius from following. Options are magnesium, chromium, bromine and krypton. If we check that these all elements present in the period number 4. As we go across the period, we know that elements present in the group 17, that is all the halogens have the smallest atomic radius. That's why if we check, then option number C is the correct answer for this question, bromine. Question number 11. Which among the following noble gases has the lowest boiling point? Options are helium, argon, neon and krypton. From that, helium is the correct answer. Option number A. Question number 12. Which from the following molecules has highest bond dissociation enthalpy? Options are bromine, fluorine, iodine and chlorine. We know that what is the trend for bond dissociation enthalpy? Chlorine has the highest bond dissociation energy, then bromine, fluorine and iodine. If we check the options, then option number D is correct answer for this, chlorine. Chlorine has the highest bond dissociation enthalpy. Question number 13. Identify the elements having smallest atomic radius from the following. Options are chlorine, phosphorus, silicon and argon. From that, chlorine is the smallest radius having element. That's why option number A is correct for this question. Question number 14. Which among the following molecules has the lowest bond dissociation enthalpy? Options are bromine, fluorine, chlorine and iodine. We know that option number D is correct answer for this. Iodine has the lowest bond dissociation enthalpy. Question number 15. Which from the following is correct decreasing order of ionization enthalpies of different elements? As we know that ionization enthalpy goes on decreasing down the group. When we are going down the group, ionization enthalpy decreases. That's why in this group, if we check, sulfur, selenium, tellurium and polonium is the correct order for the decreasing order of ionization enthalpy. Then if we check the options, from that option number A is the correct answer. Question number 16. Identify the elements having highest density from the following. Elements options are oxygen, sulfur, selenium and tellurium. We know that density of these elements as we go down the group, it goes on increasing. Here it is asked element having the highest density. Then we have the option number D. Tellurium is the correct answer for this. Question number 17. Identify false statement from the following. Options are option A. Boiling point of sulfur is lower than the oxygen. Option B. Ionization enthalpy of group 16 elements gradually decreases from top to bottom. Option C. Group 16 elements have lower ionization enthalpy than group 15 elements in the corresponding periods. Option D. Oxygen has highest electronegativity next to fluorine amongst the all elements. From that, option number A is the correct answer for this question, because whatever the boiling point of oxygen, it is written lower than the sulfur, but if we compare, oxygen has the low melting and boiling point as compared to the sulfur. That's why option number A is correct answer. Question number 18. Which from the following is a correct decreasing order of ionization enthalpy for different elements? Here different elements which are argon, neon, sulfur and chlorine. These are the different elements given to us. Then we have to find out the ionization enthalpy of them. But from that, some elements are in the same group and some are in the same period. Then if we have to consider in the both ways. Now if we check, the ionization enthalpy goes on decreasing down the group due to the increase in atomic size. Therefore, the ionization enthalpy of neon is more than the argon. And if we check the ionization enthalpy across the period, it goes on increasing with the increase of atomic number. Therefore, ionization enthalpy of sulfur, chlorine and argon is in the order of sulfur has the less ionization enthalpy than the chlorine, and chlorine has the less ionization enthalpy than the argon. And if we check that all the whatever the conditions, then we will get the option number B is the correct answer for this: neon, argon, chlorine and sulfur. Like this, ionization enthalpy goes on decreasing. Question number 19. Which from the following elements is in liquid state at the room temperature? We know that this question get repeated. Option number B is correct answer for this: bromine present in the liquid state at room temperature. Question number 20. Identify the element having positive electron gain enthalpy. That is, option A is the correct answer for this question. Neon has the positive electron gain enthalpy because other all elements have the negative electron gain enthalpy. Question number 21. Which from the following is a correct decreasing order of ionization enthalpies of different elements? Different elements given: argon, krypton, bromine and krypton, bromine and selenium. We have to check this ionization enthalpy along the group and across the period also. Ionization enthalpy decreases as we go down the group. That's why ionization enthalpy of argon is more than the krypton. Now if we check it is in the across the period, ionization enthalpy goes on increasing as the atomic number goes on increasing. That's why ionization enthalpy of selenium, bromine and krypton, if we check, selenium has the less ionization enthalpy than the bromine, and then bromine has the less ionization enthalpy than the krypton. Then if we make this order, correct order will become argon, krypton, bromine and selenium. Then if we check the options, option number A is the correct answer for this. Question number 22. Which element from the following has positive electron gain enthalpy? Options are argon, fluorine, bromine and sulfur. We know that all the inert gases have the positive electron gain enthalpy and other elements have the negative gain enthalpy. If in the options any inert gas is given, you have to tick that only for the positive electron gain enthalpy. That is, option number A is correct answer for this question. Question number 23. Which element from the following has the lowest density? Helium, neon, argon, krypton. Option number A is correct answer for this. Helium has the lowest density. Question number 24. Identify color of fluorine gas: yellow, greenish yellow, red or violet. Option number A is correct answer for this. Fluorine has yellow in color. Question number 25. Identify the color of iodine gas from the following. Options are yellow, greenish yellow, red or violet. From that, option D is the correct answer. Iodine has violet color. Question number 26. Which element from the following has the lowest value of ionization enthalpy? Now we have discussed like these questions, many questions we have discussed. We have to check along the period across the group and we have to decide which element has the lowest or greatest ionization enthalpy. If we check for this question, options are phosphorus, sulfur, chlorine and argon. From that, sulfur has the lowest value of ionization enthalpy. Question number 27. Which from the following is a correct order of arrangement of dihalides according to the decreasing bond dissociation enthalpy? From that option, if we check, option number C is the correct answer. Question number 28. If A, B, C, D are four different elements with outer electronic configuration as A element have 4s/4p4 electronic configuration, then B has 4s/4p3 4p5 and C have the 5s/5p 5p4 and D has the electronic configuration 5p5. As we know that ionization enthalpy decreases down the group and increases from left to right. Now here we have to consider that is down the group 4 and then we have to consider it in the across the period, because fourth period and fifth period atoms are given. Some atoms present in the fourth period and fifth period. As we go from left to right, that ionization enthalpy goes on increasing. That's why if we make the order of these elements, then it will become B, A, D, C. And which element have the highest ionization enthalpy? Will B element have the highest ionization enthalpy. Question number 29. Identify the elements having the highest value of first ionization enthalpy. Now we have solved like these questions many times. We have to check across the period, down the group, and we have to arrange the elements. If we all arrange these all options, then what is the order we get? Selenium, bromine, xenon and argon. Then from that, selenium has the lowest ionization enthalpy value and argon has the highest value of first ionization enthalpy. Then option number D is the correct answer for this question. Question number 30. If four different elements A, B, C, D having outer electronic configuration, it is given electronic configuration of A, B, C, D elements, and it is asked identify the elements with lowest ionization enthalpy. If we arrange these groups according to their electronic configuration, then they will belongs to the period 3 and 4, and they will come in the group 16 and 17. As we know that across the period, ionization enthalpy goes on increasing, and as we move down the group, ionization enthalpy will goes on decreasing. That's why if we compare these all elements A, B, C, D, then C only have the lowest ionization enthalpy as compared to the other elements. Then option number C is the correct answer. Question number 31. Which from the following elements has the lowest boiling point of any known substances? Then options are oxygen, helium, neon and fluorine. From that, option number B is the correct answer, helium. Question number 32. Which from the following group 16 elements has lowest negative electron gain enthalpy? Options are polonium, selenium, sulfur and oxygen. From that, option number D is the correct answer, because this oxygen has the smallest atomic size. That's why its negative electron gain enthalpy is lowest. Question number 33. Identify the element with lowest electronegativity. How to solve this question? Like this question, previously we have solved electronegativity of the elements A, B, C, D given. Then we have arranged them like that. O and S, then fluorine and chlorine, oxygen, sulfur, fluorine and chlorine. If we check their electronegativity, down the group it is decreases and along the period it goes on increasing. Then sulfur will be the correct option for this question. Question number 34. Identify the element having lowest first ionization enthalpy. Options are polonium, tellurium, bromine and krypton. From that, option A is the correct answer for this question. Question number 35. Which is the value of electronegativity of oxygen? Options are 4, 3.5, 2.48, 3.2. Then for this question, option number B is the correct answer, 3.5. Question number 36. Which from the following elements has highest value of ionization enthalpy? Helium, argon, chlorine, iodine. From that, option A is the correct answer for this question. Helium has the highest value of ionization enthalpy. Question number 37. Which element from following has largest atomic size as compared to the other three? Options are sulfur, selenium, chlorine and bromine. As we know that atomic size increases down the group and increase in the number of quantum it is increasing number of shells or orbits, and it is goes on decreasing from the left to right as the number of orbits will be remain same. Therefore, increasing order of the atomic size will become chlorine, sulfur, bromine and selenium. For this question, option number B will be the correct answer. Selenium has the largest atomic size as compared to other three. Question number 38. If four different elements A, B, C, D having electronic configuration as given here, identify the element with largest atomic radius. Options are A, B, C, D. Now see that for calculating this, what is the atomic radius is larger, then how we can only by observing we can say that this element have the more atomic radius. If we check the number of electrons and principal quantum number of these elements, then we can see principal quantum number of element C is bigger than the as compared to other elements. Then option number C will be the correct answer for this question. Question number 1. This question is depends on the anomalous behavior of the oxygen and fluorine. From that only these two questions PYQs are asked. That's why here question number 1 given again. Which among the following elements does exhibit anomalous behavior with its group element? Then for this question option number D is the correct answer. Oxygen. Question number 2. Identify the element having anomalous behavior as compared with the other members of the group. Here option number A is the correct answer. Fluorine has the anomalous behavior along the halogen group.